Okay, next is our third sub question, which is 6x square minus 3x plus, sorry, minus 3x, 3 minus 7x. So this is our third sub question. Now, how can we solve this? So the question is 6x square minus 3 minus 7x. Now, if you want to write it in the standard form, it's 6x square minus 7 minus 3. Now, we need a product of minus 18 and a sum of minus 7. So we need a product of minus 18 and a sum of minus 7. So we can look for the factors of 18. So we have 6 comma 3 and we have 18 comma 1 and we have 9 comma 2. So these are the possible factors of 18. Now we need a sum of minus 7. So we can take this 9 and 2. So 9 minus 9 plus 2, we will get 7. So I'm using that. So this we can write it as 6x square minus 9x plus 2x minus 3. So this 3x as common. Now 2x minus 3 plus 1 into 2x minus 3. So this will become 3x plus 1 into 2x minus 3. Now if we are putting this equation to 0, we will get either 3x plus 1 equal to 0 or 2x minus 3 is equal to 0. So that means x equal to either minus 1 by 3 or x equal to 3 by 2. So these are the two possible values. Now we can assign alpha is equal to minus 1 by 3 and beta is equal to 3 by 2. Now here alpha plus beta, it's minus 1 by 3 plus 3 by 2. So we have to cross multiply this, then we will get minus 2 plus 9 by 6. So this will become 7 by 6. Now let's look here. Minus b by a. B we have minus 7 and a we have 6. So this is same as minus of minus 7 by 6. Okay, so this is same as minus b by a. So hence verified. Now alpha into beta, we have minus 1 by 3 into 3 by 2 is equal to. So this will become minus 3 by 6. So this is what we are getting. So here if you see, we can say that C is minus 3 and also 6 is our A. So this is also equal to C by A. So no problem, that is also verified. Now moving further, this was our third sub question, okay? This was our third sub question. Now fourth sub question. Fourth one, 4u square plus 8u. 4u square plus 8u. So the question is 4u square plus 8u. So if you look at the question itself, you can see that in both we have 4u as common. So we can take it outside. So 4u into u is 4u square. So u plus 2. This is what we are getting. So now it's in the factorized form. So either 4u is equal to 0 or we can say u plus 2 is equal to 0. So either u is equal to 0 or u is equal to minus 2. So these are the two values. So alpha is equal to 0 and beta is equal to minus 2. So alpha plus beta, or the sum of the zeros, alpha plus beta, or the sum of the zeros is equal to 0 plus minus 2, which is equal to minus 2 itself. Can we say this as, can we write this as minus b by a? Here b is 8 and a is 4. So minus of 8 by 4, which is our minus b by a. So this is also verified. Now alpha into beta, we have u0 into minus 2, which is 0 itself. Now we don't have a constant term here, so our constant is 0. So we can write this as 0 by 4. It will still be 0. So this is c by a. This is also verified. Now moving to the next question, which is our fifth question. So fifth question is t square minus 15. So t square minus 15 we have to factorize. So for t square minus 15, what we can do? We have done something similar in the previous questions. So it's t square minus 15. How can we write this? It's like a square minus b square, which is equal to a plus b into a minus b. So we can use this here. So t square minus 15 will be equal to t plus root 15 into t minus root 15. So either t is equal to root minus root 15 or t is equal to root 15. So these are the values of our alpha and beta. So alpha is equal to minus root 15 and beta is equal to root 15. Now what is alpha plus beta? Or the sum of the zeros? We will get minus root 15 plus root 15. We will get it as 0. Now what was our b here? There is no b. B is not here, so it will be 0, and a is our 1. So we can write this as 0 by 1. Okay, so this is our minus b by a. Now alpha into beta, we can write it as minus 15 into minus root 15 into minus root 15 into root 15. So root 15 into root 15, it's 15. So it's minus 15 by 1. Now can we write this in any form like c by a? So here our c is minus 15 and a is 1. So it's c by a. And that is also verified. So that's about our fifth question. Now sixth question, we have 3x square minus x minus 4. So this was our fifth question. Now next is our sixth question. So our sixth question is 3x square minus x minus 4. So here a is 3, b is equal to minus 1 and c is equal to minus 4. So we need a product of minus 12 and a sum of minus 1. Product of minus 12 and a sum of minus 1. So we need to find out the factors of 12. So 12 we have 12 comma 1, or we have 4 comma 3. So I think this is possible. So when we subtract 3 from 4, we will get 1. is possible. So when we subtract 3 from 4, we will get 1. So we can use that logic. So this will become 3x square minus 4x plus 3x minus 4. And that will become, okay, we can take the x as common. So 3x minus 4 plus 1 into 3x minus 4. So this will become x plus 1 into 3x minus 4. Now if you are putting zeros to the given polynomial, then we will get either x equal to minus 1 or x equal to 4 by 3. So these are the values. Now alpha is equal to minus 1 and beta is equal to 4 by 3. So then alpha plus beta is equal to what? Or the sum of the zeros is equal to minus 1 plus 4 by 3. So minus 1 plus 4 by 3. On cross multiplying, what we will get? We will get 1 by 3. Now if you see here, we have b as minus 1 and a as 3. So this we can write it as minus of minus 1 by 3. So this is equal to our minus b by a. So it's verified. Now alpha into beta, it's minus 1 into 4 by 3. So this will become minus 4 by 3. Now if you see here, we have c as minus 4 and a as 3. So no problem. It's c by a. That is constant by the coefficient of x square. So that is also fine. That is also verified. So I hope this is clear. We have solved the 6 sub questions. Now this is our second question. Here we have to find the quadratic polynomial, each with the given numbers as the sum and product of its zeros respectively. So first we have 1 by 4 and minus 1. So the sum. So if we have a quadratic polynomial ax square, so let's just write, let alpha and beta be the zeros of polynomial ax square plus bx plus c. Okay, then we have alpha plus beta is equal to 1 by 4 and alpha into beta is equal to minus 1. Okay, so this means 1 by 4 is equal to minus of minus 1 by 4, which is equal to minus b by a. And here this we need it as c by a. So first we got it here, b as minus 1 and a as 4. If b is minus 1 and a is 4, we need something like this here. We need a 4 here and c we need something. And this should also give us minus 1. So minus 4 I can write here. So minus 4 by 4 is minus 1 itself. So this can be correct. So this will give us c by a. So from this what we got? We got the b as minus 1, a is 4 and c as minus 4. So using this we can form an equation. So ax square, so 4x square minus, plus, so plus b it is, so it's here 1, so minus x, 1x plus c, so it's minus 4 is the required polynomial. Is a required polynomial. In the same way, we can do all the other questions. So next is root 2 and 1 by 3. So for root 2 and 1 by 3. So same, you have to repeat the same sentences that let alpha and beta be the zeros of the polynomial ax square plus bx plus c is c. Then we can say that alpha plus beta is equal to root 2 plus 1 by 3, which we have sorry, these are not the zeros. So we have alpha plus beta as equal to root 2 and alpha into beta is equal to 1 by 3. So here we are getting c by a. Here we are getting a as 3. So what we have to do here is we have to multiply and divide root 2 with 3. So 3 root 2 by 3. So this again we can write it as minus of minus 3 root 2 by 3. So this will be equal to minus b by a. So here b is equal to minus 3 root 2, a is equal to 3 and c is equal to 1. So this is what we are getting. So using this we can form an equation which is 3x square. Okay, now b is minus 3 root 2x plus 1 is the required quadratic polynomial. Now next, that is our third one. We have the sum as 0 and the product as root 5. So 0 and root 5. So for 0 and root 5, we have alpha plus beta is equal to 0 and alpha into beta is equal to root 5. So this we can write it as root 5 by 1. So that means c by a. So c is equal to root 5 and a is equal to 1. So here we can write this as 0 by 1. So minus b by a. So that means b is equal to 0. Then we can form the equation or sorry the polynomial as ax square, so 1x square, so x square plus 0 into x plus 0x plus root 5. This is our required polynomial. Or you can just write it as x square plus root 5. This is also fine. Now moving to the fourth question. So for fourth question we have 1 and 1 as a sum and the product of the zeros. Now for that, fourth question 1 comma 1. So alpha plus beta, you have to write the starting, that is again alpha and let alpha and beta be the zeros of the polynomial ax square plus bx plus c is equal to 0. Then you can write this step that alpha plus beta is equal to 1 and alpha into beta is equal to 1. So to make it, we can write this as 1 by 1 and this will become minus of minus 1 by 1. So this is minus b by a. So our b will be minus 1, and here again it's c by a. So a is 1 and b is minus 1 and c is again 1. So our required polynomial will be x square minus x plus 1 is the required polynomial. Okay. Now the fifth question. The fifth question is minus 1. Okay. Now the fifth question. The fifth question is minus 1 by 4 and 1 by 4. So minus 1 by 4 and 1 by 4 are the sum and the product. Fifth, minus 1 by 4 and 1 by 4. So for minus 1 by 4, what we are getting? We are getting alpha plus beta as minus 1 by 4, and alpha into beta we are getting 1 by 4. So here this is our c by a, and here we are getting minus b by a. So that means b is equal to 1 and a is equal to 4 and c is equal to 1. So our required polynomial will be 4x square plus x plus 1 is the required polynomial. So 4x square plus x plus 1 is our required polynomial. Now next is the required polynomial. Now next is our sixth sub question, which is 4, 1. So for sixth sub question 4, 1. Okay, sixth sub question 4, 1. So here the sum of the zeros. So if alpha and beta are the zeros of the polynomial ax square plus bx plus c is equal to 0, we can say that alpha plus beta is equal to 4 and alpha into beta is equal to 1. So we can write this 4 as 4 by 1 or minus of minus 4 by 1. We can write the 1 as 1 by 1. So this will be equal to c by a, and this will be equal to a minus b by a. So a is equal to 1, b is equal to minus 4, and c is equal to 1. So our required polynomial will be 1x square plus bx. So here we have minus 4x plus c. So plus 1. This is our required polynomial. X square minus 4x plus 1 will be our required polynomial. I hope this is clear for you. So in this particular chapter, we have only seen different types of polynomials that are linear, quadratic, and the cubic polynomials. Then we have seen the definition of a quadratic polynomial. So a quadratic polynomial in x with real coefficients is of the form ax square plus bx plus c is, and where a, b, c are real numbers and a is not is equal to 0. Okay, what will happen if a is 0? If a is 0, there won't be a x square term, then it will become a linear polynomial. Okay, if it is a quadratic polynomial, then a should not be 0. Now, the zeros of a polynomial, how we will verify if it is a 0 of a polynomial? We have to put p of k is equal to 0. In the place of k, you can put different values. If it is giving 0, then that particular value will be our 0 of the polynomial or the solution of the polynomial. Now, a quadratic polynomial can have at most 2 zeros and a cubic polynomial can have at most 3 zeros. Now, what about a linear polynomial? It can only have at most 1 0. Okay. Now, if alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c, then we have See, in the sum of the zeros is minus b by a and the product of the zeros is c by a. Now next, for a cubic polynomial, we have seen that alpha plus beta plus gamma, or the sum of the zeros are minus b by a, and alpha into beta plus beta into gamma plus gamma into alpha, we are getting c by a. And again, the product of the zeros, we are getting minus d by a. So these are the main things we have seen in this particular chapter.